Let's say you have a project you're building that you want to make move. It doesn't matter what you're building. It could be a robot, an RC car, a conveyor belt, or even sharks with lasers attached to their heads.
I have one simple request, and that is to have sharks with frickin' laser beams attached to their heads.
Okay, well maybe not those, but you get the idea. In order to add motion to your project, you're going to need a motor. And while it's possible to connect your motor to a power source like a battery, you're probably going to want to have control over the speed and direction of it. So in order to do this, you're going to need a motor driver. In this episode, we're going to be taking a look at motor drivers for brushed DC motors. So let's begin. So in my case, I'm building a robot. And while I could connect the motors directly to a battery and make the rover move, I still want to have control over the direction and speed of the robot. So I needed to find a way to control all of the motors that's both simple and efficient. So let's first take a look at how we could control the speed of a motor. As anyone who's worked with DC motors will tell you, the more voltage you apply to a motor, the faster they will go. So in order to control the speed, we could just simply add a variable potentiometer. As you increase the resistance of the potentiometer, the voltage across the motor decreases. This would give us the control that we need. However, whatever energy you don't use to power the motor has to go somewhere. And unless you have a potentiometer designed to be able to deal with the energy loss, the results could be dangerous. So we need to be able to control the motor efficiently and safely. Fortunately, we can use something called pulse width modulation, or PWM for short. So let's take a look at how that works. Let's say you have a 12-volt battery attached to a motor with a switch in the middle. And let's say that at 12 volts, the motor will rotate at 500 RPM. If you turn the switch on and leave it on, the motor will rotate at 500 RPM as it will receive a full 12 volts. But let's say we want to rotate the motor at 250 RPM, or approximately half of its normal speed. We would need to reduce the voltage to approximately 6 volts. Fortunately for us, the motor's speed cannot instantaneously change. So if we're able to turn the switch on and off fast enough, we can control the average voltage across the motor. So essentially, pulse width modulation is simply just turning a switch on and off very quickly and controlling the amount of on time versus off time. This on time is usually referred to as the duty cycle. The duty cycle simply represents how long the device is on versus how long it's off. Instead of a manual switch, we could instead use a transistor connected to something like a microcontroller or another timer circuit. This can allow us to have very accurate speed control over the motor and is very efficient. So now that we've figured out how to control the speed of a motor, we now need to learn how to control the direction. With DC motors, in order to change the direction, you simply reverse the poles of the supply that you're using. However, this isn't a practical solution. So we have to be able to do this automatically. For this, we turn to the trusty H-bridge circuit. Let's take a look at that. Here we have the H-bridge circuit. They call it the H-bridge circuit because it looks like an H. So, as you can see, you have a motor in the center surrounded by 4 switches. And then the top is connected to your positive and the bottom is connected to the negative terminal of the battery. So if we want to rotate forward, we can simply turn on switches 1 and 4. This will connect the motor in a forward direction and allow the motor to rotate clockwise. However, if we want to rotate in reverse, we simply turn off 1 and 4 and turn on 2 and 3. This will reverse the poles on the motor and the motor will rotate backwards. However, it's not recommended to turn off switch on at the same time. And instead of manual switches, we could simply use a microcontroller and transistors. And if you use pulse width modulation on this circuit, you not only can have control over the direction, but also the speed. Excellent! So I hope you guys enjoyed that episode of how motor drivers work. I can't wait to see what you guys come up with. And I look forward to you guys using the H-bridge circuit in your future projects. I can't wait to see what you guys build. Thanks for watching. Catch you next time.